Question number 9, 2023, paper CC11, Probability and Statistics, semester 5, CBCS. Question 9, by applying central limit theorem to a sequence of random variables with Poisson distribution, prove that limit n tends to infinity e to the power minus n summation r equal to 0 to n to the power r divided by r factorial equal to half. Now, we know a discrete random variable x is said to have Poisson distribution with parameter lambda greater than 0 if the probability mass function PMF is given by fx equals to e to the power minus lambda to the power x divided by x factorial for x equal to 0, 1, 2, comma dot 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 and elsewhere 0. Let capital X1, capital X2, capital Xn be a sequence of independent and identically distributed IID, independent and identically distributed random variables, each following a Poisson distribution with parameter lambda equal to 1. For each xi, I equal to 0, 1, 2, dot, 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 mean mu equal to expectation of xi. So this lambda, this equals to 1 because parameter lambda equal to 1. Variance sigma square equal to variance of xi equal to lambda, this equal to 1. We already know this result, mean mu for Poisson lambda distribution, this is equal to lambda, and variance sigma square equal to lambda. Let x bar, this equals to summation of xi I equal to 1 to n whole divided by I n. This is the mean of this x bar, x1 plus x2 plus xn whole divided by small n. Now the central limit theorem for equal components, let xn be a sequence of independent and identically distributed random variables and expectation of xn equal to m and variance of xn equal to sigma square for all n, then x bar minus m whole divided by sigma by root n is asymptotically normal 0-1 variate. Actually, normal 0-1 means standard normal variate. Asymptotically means when this small n tends to infinity, and this tends to normal 0-1 as n tends to infinity. And that is x bar is asymptotically normal mean m with standard deviation sigma by root n variate. Hence, by the theorem, x bar is asymptotically normal 1, 1 by root n because m equal to 1, already we have proved m equal to 1, this, and variance is also 1. So sigma by root n, sigma 1 by root n. So x bar minus 1 whole divided by 1 by root n converges in distribution to standard normal variate u. This is the n01 as n tends to infinity. Therefore, limit n tends to infinity, probability of x bar minus 1 whole divided by 1 by square root n less than equal to 0, and this equal to probability of, this is the standard normal variate u less than equal to 0, and this equals to half because a standard normal distribution is symmetric about a mean. Actually, this is the standard normal distribution, standard normal distribution is this. So this is the mean 0. So less than equal to 0 means this portion, this area, and this area is equal to 0.5, and this area is 0.5. So standard normal distribution is this, probability of standard normal variate u less than equal to 0 is minus infinity to 0. So minus infinity to 0, this area, under this area, this density curve, 1 by square root of 2 pi e to the power minus x square by 2 dx equal to half. So this equals to half. Now probability of this equals to x bar minus 1 less than equal to 0, because 1 by n into 0 is 0. So probability of x bar less than equal to 1, and x bar is this x1 plus x2 plus xn less than equal to n, because x bar means x1 plus x2 plus xn whole divided by n. So this less than equal to small n. Let this x1 plus x2 plus xn equal to Sn, new variable Sn, a random variable, probability of Sn less than equal to n. So ultimately you get this limit probability of Sn less than equal to n, this is equal to half from 1 and 2. According to reproductive property, actually the additive property here of the Poisson distribution, some of the independent Poisson variables means here x1, x2, xn, independent variables, that is here xn, it also follows the Poisson n distribution. So Sn here, that is Sn here, follows the Poisson distribution. Independent variables here, that is Sn, also follows Poisson n distribution. So probability of Sn equal to r, particular any value of r, discrete random variable. So e to the power minus n to the power r by r factorial by the Poisson n distribution. So probability of Sn less than equal to n means r equal to 0 to n, means the Poisson distribution starts from r equal to 0, 1, 2, dot, 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 n. So less than equal to means r equal to 0, r equal to 2, 1, r equal to 2, sum of all these values. So summation r equal to 0 to n e to the power minus n factorial by r factorial. So this e to the power minus n independent of r, taking outside of the summation and using 1, 2, and 3. From 1 we get this equals to half, and this probability is less probability of this. So probability of Sn is equal to this. So we get limit n tends to infinity, this e to the power minus n summation of this n to the power r factorial, this is equal to half. Thank you for watching this video.